Mike Cadillac. I'm the founder and inventor of a company called Windtech. We make the most advanced wind turbines in the world in the 2 to 20 kilowatt range. I understand you have some questions for me?
Yeah, Mike, so tell us what we're looking at here.
All right, so this has been our 5 kilowatt prototype that's been up on site in Glen Cove for the last 2 years. This is where we pulled a lot of our data and looked at stress analysis. And we have now sold this to University of Minnesota Duluth campus, and they're putting it up on their farm out there.
Now you mentioned the ZCT system. Explain what this is.
Sure, but first let me kind of, so you get familiar, I'll take you from the nose all the way to the back, all right? So first of all, this is the main shaft. This is where the blades go on to. This is our main bearing. This is a kind of a very important part because there's a lot of transitional torque and rotational torque that happens in here. So what we did was we developed a two-way main bearing. So it handles the loads going towards the system and also any loads that come away from the system. It's pretty much locked in there and she's not going anywhere. This is our one of our brakes that we utilize. This is the ZZT. Now let me explain the ZZT. It's called the zero contact transmission. You'll see it operating here in a minute. This is our secondary safety brake. We have 5 generators. Yes, 5. 1, 2. On the other side is 3, 4. It's actually duplicated exactly how you see it here. And then the 5th one is our main generator. Now what that does is that goes on our main shaft, very similar to a direct drive system. These 4 generators are on the outside are high-speed generators, similar to what a system uses in a gearbox. What we've been able to do is marry the two together in perfect harmony, both with a main generator, direct drive, and 4 planetary drives as high-speed generators. So if you want to go ahead and turn on it, I'll explain what the zero contact transmission means. This main shaft, if it does 100 RPM, these shafts on the outside are doing 500. It's a 5-to-1 increaser. So by using this piece of paper here, I will demonstrate that there is absolutely no contact between one system or the other. Now what we're using here is neodymium magnets as the driving force between the 2 shafts. That way we don't have to introduce any power into the system to create the magnetic field. As you can see here, just on the rotational side, this one is doing about 50 RPMs right now, and this is doing 5 times that, so 250 RPMs. So you have some more questions?
Yeah, Mike, so if there's no contact, then I assume that there's no lubricants that are required?
Absolutely not. So in any gearbox, you have to have lubricants because it has to disperse the friction, which is heat. The heat is also what we call energy loss. Since we have no friction here, no energy loss, no need for lubricants. It's also important in Minnesota or cold climate weather because lubricants have a tendency to, well, everybody knows, go out to start your car in the middle of the winter, they go, That's pretty much due to the viscosity of your oil.
How about the cost effectiveness of this system compared to others?
Well, a lot of the stuff that we use here is off the shelf. So we buy from vendors. These vendors are the ones that make the brakes and the generators, and basically we do a lot of assembly other than the ZZT, which is our own proprietary. We have multiple patents on it.
What's the expected life of a system like this?
Well, as you know, everything breaks, and that's why we have one of the best warranties in the industry. However, this ZZT, because of the zero contact, there's no parts actually intermingling with one another. There's nothing really wearing out. The bearings don't have the side loads that normal bearings have, so the expected life expectancy of this system was done through St. Thomas, through their ANSES program, at 20 years at 3,600 RPMs, 24 hours a day for 20 years. Not a problem. Now, we expect higher life efficiency because we're only operating between 500 to 700 RPMs on our output and 100 RPMs to our input.
So how efficient is a system like this compared to others?
Well, let's take a look at it. So if you were to take a look at most direct drive systems, what that means is you have a set of blades and you have one large generator. So that one large generator needs a tremendous amount of torque to turn and produce power. And RPMs, rotations per minute, and torque are relative to horsepower. So the higher the RPMs, the less torque you need. So what we've done in this system, in low winds, wind has a certain amount of power in it. So in lower winds, there's not a lot of power. So what we've done is we've converted that low torque into high RPMs, and we're able to much more efficiently generate power. So in our low wind scenario, from 7 to 18 miles per hour, we produce a vast amount more kilowatts per hour because of that. The other thing is as far as the competition, if you have one large generator and that generator breaks, your whole system is down. Not only that, it takes a long time for you either to rebuild that generator or ship it in and replace that generator. With our system, we have 5 generators. So if this generator here goes out, one, you can still operate this system because its magnetic field will fail. So if this generator freezes up, this will freeze up. It will not affect the other generators. Now we can demonstrate that by applying the brakes. So if you want to apply the brakes. So everything here is locked up. This system is still going. You want to turn on the brakes or off the brakes. So, there we go. Now that is actually a thing of beauty, because if you think about this axle at a high speed, this one catching up to it, it's an amazing process. Now, I forgot, where was I?
I'm not sure. You were talking about the brakes.
Okay, so if this generator goes out, the other 4 generators still make power. The ease of changing this one out, we can change it in 2.5 hours, and it's an off-the-shelf part, so we can be in and out in no time at all.
Well, it seems like a very friendly system.
Absolutely. There is no system like this in the world. No one has anything like this. In summary, we take the torque from the wind, we convert it through the ZZT, and make power here. And we do it in the most efficient way with the most unique wind turbine in the world.